Data obtained by observing actual behavior outside an experimental setting are called observational data. Observational data are collected using surveys such as telephone surveys of consumers and administrative records such as historical records on mortgage applications maintained by lending institutions. Observational data pose major challenges to econometric attempts to estimate causal effects, and the tools of econometrics are designed to tackle these challenges. In the real world, levels of treatment, the amount of fertilizer in the tomato example, the student teacher ratio in the class size example, are not assigned at random, so it is difficult to sort out the effect of the treatment from other relevant factors. Much of econometrics and much of this text is devoted to methods for meeting the challenges encountered when real world data are used to estimate causal effects. Whether the data are experimental or observational, data sets come in three main types: cross-sectional data, time series data, and panel data. In this text, you will encounter all three types. Cross-sectional data, data on different entities, workers, consumers, firms, governmental units, and so forth, for a single time period are called cross-sectional data. For example, the data on test scores in California school districts are cross-sectional. Those data are for 420 entities, school districts, for a single time period, 1999. In general, the number of entities on which we have observations is denoted in. So, for example, in the California data set, N equals 420. The California test score data set contains measurements of several different variables for each district. Some of these data are tabulated in Table 1.1. Each row lists data for a different district. For example, the average test score for the first district, District 1, is 680.8. This is the average of the math and science test scores for all fifth graders in that district in 1999 on a standardized test, the Stanford Achievement Test. The average student-teacher ratio in that district is 17.89. That is the number of students in District 1 divided by the number of classroom teachers in District 1 is 17.89. Average expenditure per pupil in District 1 is 6,385. The percentage of students in that district still learning English, that is, the percentage of students for whom English is a second language and who are not yet proficient in English, is 0%. The remaining rows present data for other districts. The order of the rows is arbitrary, and the number of the district, which is called the observation number, is an arbitrary assigned number that organizes the data. As you can see in the table, all the variables listed vary considerably. With cross-sectional data, we can learn about relationships among variables by studying differences across people, firms, or other economic entities during a single time period. See Table 1.1, selected observations on test scores and other variables for California school districts in 1999. You have observation number, district average, test score, student-teacher ratio, expenditure per pupil, and percentage of students learning English.